So today we're going to be talking about composition of transformations. It's important you understand what it means to be a composition of transformations. That means more than one. So where you're doing multiple transformations. So first I'll do something, then I'll do something else, then I might do something else. So sometimes they call it a composition of transformations, or sometimes they say a sequence of transformations. If I say a sequence, it also means more than one. All right, so the notation for a composition, there's specifically this circle that you'll see between something like, if I say a dilation of 2 and a reflection over the x-axis. So I think I have an example down there. Yes, I do. So this is the notation right here for a composition. It's not always used, but if it is used, you have to work backwards. So what that means, if I want you to do this composition of transformations to triangle ABC, you're going to have to first reflect it over the x-axis, then you'll dilate it by 2. Why does it matter is because composition of transformations is not commutative, meaning sometimes it works where I could go forwards or backwards, I'll still get the same answer, but many times it does not. So it's important if they use this notation that you go backwards. Now sometimes they won't use the notation. They might just tell you, okay, step 1, do this, then step 2, do that. So for example, I might say, and here I'll write it with the notation, let us do exactly what this says. Let us translate -2, 3 and reflect over line L for triangle ABC. Let's see. All right, so I need to make a line. I'm going to call this line L. Okay, and ABC is going to start here. So here's triangle ABC. Now remember, I told you the first thing you have to do is you have to work backwards. So I'm going to take triangle ABC and I'm going to reflect it over line L first. So it will end up here. Now it depends on if they ask you to label it. So here's the middleman right here. Then it asks us to translate -2, 3. So that means left 2 and up 3. So let's say left 2 and up 3. So every point is going to do this. And I'll just try and keep it consistent. So that my new points will end up right here. So here's my A prime, B prime, and C prime. Notice how I labeled it A prime, B prime, C prime after doing both transformations. So here I did the flip, the reflection, and then here I did my move, okay, because the move is for the transformation. So I work backwards. That's called the composition of transformations or a sequence of transformations. And you can use that to, it's really important though to make sure you know your transformations. You can use that to do multiple things to an image. Okay, so I just want to do a couple examples with you. I have a lot of examples, but just 2 for now. So I'm going to start with this one right here. So I have A, B, C. And I always like to write my coordinates on the side so that I can always, because it says, sometimes it says state the coordinates. So I like to have them written on the side here so I could do the math to them as well. So 0, 9 is A, B is -3, 0, and -6, 9 So here is, maybe I could use some straight lines. So this is my original coordinate. A, B, C. My pre-image, the start. Now it says, graph and label. So this is not written, notice, it's not written in the notation. It's step A, B, C, and D. So it says, graph and label the prime, which is the image of ABC after a reflection through the origin. So a reflection through the origin means every point is going to go through the origin and end up on the other side. Through the origin and end up on the other side. Through the origin and end up on the other side. So I can already tell where the points are going to end up. So if I'm going to reflect through the origin to get A prime, B prime, and C prime, I'm going to end up B prime will end up at positive 3, 0. A prime will end up at 0, negative 9. And C prime will end up at 6, negative 9. Then it says, look at this next problem. It says, find A double prime, B double prime, and C double prime, which is the image of the prime. So don't start with the original coordinates. Now start with the prime coordinates and dilate by 1/3. So everything should be 1/3. So that's kind of easier just to do with the coordinates. So 1/3 of 0 is 0. 1/3 of negative 9 is negative 3. 1/3 of 3 is 1. 1/3 of 0 is 0. 1/3 of 6 is 2. And 1/3 of negative 9 is negative 3. And you can always just put in the calculator. 1/3 times 6. 1/3 times negative 9. And it'll easily spit out the correct answers or coordinates for you. So 0, negative 3, 1, 0, and 2, negative 3. So here is my double prime. A double prime, B double prime, and C double prime. Then, one last step. It says, I want to graph triple prime. Oh, but it's the image of the double prime. So use the double prime points to get the triple prime. It says translate 5, 4. So that means to the right and up. So to the right, 5, 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. So there's my B triple prime. So I started with that one because then the other two are a little bit easier to draw after. So here's my A triple prime and my C triple prime. And there you have it. There are my coordinates. And I always like to state them. It's a good habit because a lot of times they ask you to graph the coordinates. So this is 5, 1. This is 7, 1. And this is 6, 4. Okay, so that's a composition of transformations. It's doing one step and then next and then next and then next. It's always using the image as your new pre-image. It's a continuation of transformations. All right, I'm going to do one more example with you just so that you can really understand how to do this. So here's another example I want to do with you. So I have these coordinates. A is negative 1, 2. B is 5, 2. And C is 3, 4. So here's A, B, C. And now if I take a look at this first, what it's asking me to do, it's saying the image of ABC to get the primes. And I want to do this composition. Notice they use the notation. I know it's It looks like there's two of them, but really what it is that this is supposed to be a degree symbol, and that's supposed to be the notation. So I'm first going to write my coordinates here. So A is -1, 2, B is 5, 2, and C is 3, 4. And I need to work backwards. So I'm going to reflect over the x-axis first, and here is my x-axis. So a reflection over that would bring me here, and here, and here. So sometimes, whatever makes you more comfortable, whether you are to, graph it first, or if you want to actually do the math first. But notice I'm not going to call this the prime because it wants us to do both of these things to get the prime. So I'm actually just going to label these points real quick. So this is -1, -2, this is 5, -2, and this is 3, -4. And then my next step is to take these and rotate 90 degrees. Now, if I want to rotate 90 degrees to get these prime coordinates, remember I have to go counterclockwise. So if this is quadrant 1, and this is 2, and this is 3, and this is 4, I have to go in the positive direction. So it's actually going to go this way, counterclockwise. So whatever coordinates are in quadrant 4, it'll end up in quadrant 1. And whatever coordinates are in quadrant 3 will end up in quadrant 4. So this is the counterclockwise direction. Okay? So I have here 5 to the right and 2 down. So instead of right and down, if I need to think about this, instead of right and down, everything is shifting this way, right? So I will be doing up and right instead of right and down. Or you could turn your paper. So instead of right and down, I'm doing up and right. So point A is, I'm doing point B. 5 to the right, 2 down should mean 5 up and 2 to the right. So here's my B prime. 3 to the right and 4 down means 3 up and 4 to the right. So here's my C prime. And then point A is 1 to the left, 2 down. So the left should now become down. So 1 down and 2 to the right. Here is my A prime. So I'm able to do that pretty easily in my head. Some of you might have a little bit more trouble, which is fine. Just make sure you know what you're doing. Okay? So there is my prime coordinates. So A is now to -1. B is now 2, 5. And C is 4, 3. Okay? Now, if I look at this second part, it says graph and label the double prime, which is the image of, now be careful, look, it says A, B, C. It does not want you to use the prime. It wants you to reuse the original coordinates. So it's very important that you note that because it'll tell you what coordinates it wants you to use. And it wants you to dilate it by 2. So that's actually pretty simple. So we're going to call these double prime. And I'm going to multiply everything by 2. And easily I can graph that. So 3 and then 4. 3 and then 4. Here's C double prime. And this is A double prime. And then 10 and 4. So this is B double prime. And here is my double prime. It is the image of my original ABC. So as long as you pay attention to what it's asking and as long as you know how to do all your transformations, then you shouldn't have any problem with this unit, with this topic. If you have any questions, feel free to reach out to me. Have a great day, everybody.